Radian measure, an introduction to sinusoidal functions. So angles are measured either in degrees, okay, so degrees you know, is what you've been working in till now. If you go once around the circle, how many degrees is that? 360. Why 360? Degrees. It's arbitrary. Somebody chose it. I blame the Babylonians, but it might have been the Mesopotamians, but neither of them around to defend themselves one way or the other. 360 is divisible by a lot of numbers. 2, 3, 4, 5, 6. Not 7, not 8, 9, 10, 12. So it is divisible by that. It's almost the number of days in a year. Okay, so maybe that has something to do with it. So what's 1 degree? So if there's 360 degrees around a circle, what's 1 degree? 1/360th, right? So if we drew a really big circle out in the football field, so that was 360 meters around, if you walked 1 meter around that circle, and we were to draw from the center of the circle, we drew a line, and then you walk that 1 meter around the edge, we drew a line, that little slice would be 1 degree, right? 1/360th of the way around. There is another way to measure angles, and it's radians. And radians make sense in that they use the radius of the circle to define what a radian is, right? Nobody has said, hey, there's 360 of these things, right? Why not 400? And there actually is a degree measurement system where it's 400 degrees around the circle, right? You ever have that old calculator in junior high with the DRG key? Well, if you look, you might see them, right? So D was for degrees, R was for radians, which we're about to do today, and G was for something, I think they're called grads or something. And there's 400 of them in a circle. It's also military, they use mils, which is about, there's 6,400 of them in a circle, right? So it's just a lot more fine measurement, but we're going to use radians. So the radian measure of an angle can be defined as the ratio of the arc length formed by the central angle. There's the central angle. This arc length here is equal to the radius. So here's a radius, here's a radius. If you measure off an arc equal in length to the radius, then this is 1 radian. 1 radian, right? That's just measuring in radians. So the nice thing about that, it's in terms of the circle itself. If that circle gets bigger, so does its radius, but the angle stays the same, right? These get longer, the arc gets longer, but it's the same. If I make a small circle here, a better circle, small circle. This will be the radius, that's the radius, that's the radius. So as the circle grows or shrinks, that angle still stays the same. It's 1 radian. It's developed from the formula, arc length is equal to the radius times the angle in radians. The arc length of once around the circle is called the circumference, which is 2 pi r. And if we divide that by the radius, we end up with 2 pi. So 1 complete rotation of the circle is 360 degrees or 2 pi radians. If you divide both of these by 2, it means 180 degrees. Half a circle is pi radians. Divide that by 2, 90 degrees is pi over 2, 45 degrees is pi over 4, and guess what you have to know about radians? That they exist and that your calculator should be in them. That's it. You do not have to know that 360 degrees is 2 pi radians, okay? So you don't need to know anything about radians except it's an alternate way of measuring an angle, and it's the way that our calculator will default into. When you reset the calculator, it will go into radians, and then you should just leave it there. That's all you need to know about radians. The basic sinusoidal function. Y is equal to A sine bx plus c plus d. Now, for those of you that have seen an alternate formula for this, the reason we use this formula is when you run a regression on the calculator, which we are fond of doing, that's the format that the regression is going to come out in. Okay? So we are going to figure out today, here's our thing we're going to do. We're going to go through, look at the graph, y equals a sine bx plus c plus d. there's the sine graph. We'll talk a little bit about its characteristics, and we'll start playing with A, B, C, D to see what's going on, right? And we'll just describe, hey, this is doing that. What is this doing? So that's moved a bit. I got to change some things here. I want that to be 1. I want that to be 1. I want that to be 0. And I want this to be 0. Not 0 minus, just 0. This is the basic sinusoidal function. Okay? Basic sinusoidal function. So its shape is that of a wave. Okay, so it's wave-like. That's what makes it sinusoidal. So a wave-like pattern. It's periodic, which means it's repeating. So by repeating, I mean, take a look at this. It's starting at the middle. It goes up, back to the middle, goes down, back to the middle, up, back to the middle, down, back to the middle. Its period is the length of time it takes to repeat. So 1 period is equal to 2 pi. Okay, 2 pi radians, right? Once around the circle, right? 360 degrees. We don't use degrees. We use radians. We don't have to know anything about them, but there are 2 pi of them. So that makes that the period of a sinusoidal function. So that'll come in handy in a moment. I like to think of a sinusoidal function as split into 4 parts. And if we take 2 pi divided by 4, we end up with pi divided by 2. So here are the 4 parts. A sinusoidal function starts at the middle and goes up. So here's the middle, and the function is going up. Starts at them. So by starts, I mean we're at the y-axis. So when we're at the y-axis and the middle, if we're starting to go up, that's a sinusoidal function. Split into 4 parts, each of which is pi divided by 2. So from the middle to the maximum, 1 part. From the maximum back to the middle, the 2nd part. From the middle down to the minimum, the 3rd part. From the minimum back to the middle, the 4th part. And we just keep repeating. So middle to max, back to the middle, down to the minimum, back to the middle, up to the max, back to the middle, down to the min, back to the middle, up, and so on. Right? So that's going to go on forever in both directions. All right, so what do A, B, C, D do? So I'm going to start with D. I'm going to press play. So what does it look like D is doing? And how's it moving? Up and down. Moving it up and down. Okay, let's pause. Well, I don't know. Let's set D to like 3 and see what happens. Okay, so I set D equal to 3, so there's 3. So what's happening? Is that the y-intercept? Yeah, looks like it. So D appears to be the y-intercept. Go here. So D, let's go back to here. So here's D. What does it appear to be doing to the graph? Like the graph goes from here to here. Where's D? In the middle. In the middle. So D is called the midline. Midline or median. So like in the middle of the road, where do they put in the middle of the road? So you have to go 5 blocks out of the way to turn left. The median, right? So the median runs down the middle of the road. And then you got to go 5 blocks further south because you want to turn left. There's the median. So you can't cross the median. So the median or the midline, it's the middle of the graph. Middle of the graph. And so the D value moves the graph up or down. Moves the graph up or down. So we change D, and the effect is that we move the graph up or down. All right, I'll give you a chance. write that down. You can sketch out a little sign if you want, throw in D, but we'll do this. You look at tomorrow's lesson, you'll see we're just going to go over this again. So everything you need to know about sinusoidal functions will be presented in the next 10 or 15 minutes. Okay? Then we'll expound upon that and we'll do some regressions and we'll look at effects of things. Okay, let's go back here. So I'm going to set D equal to 0. So if we're going to change things, it's better to change one thing at a time, right? So here we are, we're back at the middle. So the middle or the median, the midline is at D is where. So what's that line? The line itself, the midline, has an equation of y equals 0. This has this right here, y equals 0. So the equation, we'll go back. So the equation of the midline, so lines have equations. So the equation is y is equal to d. So if I move everything up 5, right? If we make d 5, everything's going up 5. The maximum value is going up 5, the minimum value is going up 5, and the middle is going up 5. So the new midline will be at y is equal to d. So if we ask you for the equation of a midline, don't write 5, right? You write y equals 5. The equation of a line got to be in the form y equals. All right, let's change A. Or not. Let's not change A. All right, what's A doing? Stretching it. How stretch? What is this stretch? Vertical stretch. Okay, so it's stretching it vertically, which is up, down, right? So A is a vertical stretch. Now, what is A? So let's set A to a value. I'm just going to set it to like 3. Why not? 3 is a good number. A is 3. So what's the maximum value? What's the minimum value? -3. So A is called the amplitude. Go back to the notes here. A is for so D is for midline or median. A is for amplitude. Amplitude. Okay. Leads off with an A, kind of handy. It's the distance from the midline to the maximum or minimum. The distance from the midline to the maximum or the minimum. Maximum or the minimum. So we saw on here that the max is at 3 and the minimum is -3. So if we made D equal to 1 and put the midline at 1, then how high up do we go? So here's the midline. We go up 3. So our maximum is going to be 4. And then here's the midline. What if we're going down? We go down 3. So from 1, if we go down 3, 1, 2, 3, we'll be at -2. So the amplitude is the distance from the midline, right, which usually is pretty easy to identify. Like if you see a graph, you can sketch it in. And on this, all I really have to do is count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 ticks. So the middle is going to be 1, 2, 3, 4, 5, 6. So I can draw in the midline. And I don't even have to know what the scale is to do that, right? It just matters, well, there were 12 ticks top to bottom, so the middle's got to be half of that, or 6. Now, if we go actual scale, and we say, well, the scale here is a half, right? This is a half, 1, 1 1/2, 2. So how far is it from the top to the bottom? Well, 1, 2, 3, 4, 5, 6 units. So the middle is going to be 1, 2, 3 of those units. Okay, and then the amplitude is the distance from the middle to the max or from the middle to the min. So that here is the amplitude. And another way to think of it is it's half the distance. Half the distance from the maximum to the min, from maximum to minimum. Okay. Now we'll put some formulas with this tomorrow. So we'll come up with some formulas. Right. Looking at your formula sheet, so for 30-2, you can see it's not that extensive on sinusoidal. It says y is equal to a times sine bx plus c plus d. So basically just the equation that we were given right here. That's on your formula sheet. All right, what else do we have that we can change? So we'll set d back to 0. Okay, we don't want to change that. We'll set a back to 1. Right, so we only change one thing at a time, and let's play with b, or not. So what's b doing? It's a horizontal stretch, right? It's stretching in a horizontal direction, left to right. Okay, so how are we going to describe that? So I'm going to set b equal to, so notice if there's no value of b, then there's no function, right? So b, there's 1. So b, okay, wait, remember we discussed that it's periodic, right? This is one period here. One period. And the regular period of a sine function is 2 pi. So if I'm going from negative 2 pi to 0. So a period is from a start place you start back to the same point. So I could start here at a maximum and go to the next maximum. And say, well, what am I doing? So this is a half, 1, 1.5, 2. Each one of those is half pi. So I have a half pi, 1 pi, 1.5 pi, 2 pi. So the period is 2 pi. I can start at a minimum and go to the next minimum. Okay, again, half, 1, 1.5, 2. I can start at the middle going up, which is where a sine function starts. So let's do that here. And go back to the middle where I'm going up again. So not here, that's the middle going down. That would be half of the period, right? We've gone through two things. From the middle to a maximum, back to the middle would be a half a period. From the middle to the maximum is 1/4 of the period, right? So one period. So b is not the period. B. So a is the amplitude. D is the midline. B is not the period. Instead, the period is equal to 2 pi divided by b. That also is on the formula sheet. Because many years ago, when it was applied math 30 and we were doing sinusoidal, the period was period always has been 2 pi divided by b, but it's not something that you guys know in the way that a 30-1 student studying sinusoidal recognizes that b is a horizontal stretch by a certain factor. And so they can get the period just knowing that, oh, it's stretched by a factor of this. And we don't do stretches, so we don't have that knowledge to be able to look at b and describe it as a horizontal stretch in certain terms. So instead, we are given on the formula sheet the formula for period. And we can rearrange this formula to say b times the period is equal to 2 pi. So b would be equal to 2 pi divided by the period. So you're not given this, but you can derive it from that. Really, all you do is just switch the b and the period. Okay. So whenever you have a formula that says something is like 2 pi over b, period is 2 pi over b, you can rewrite that formula just switching those two. And that's why it happens, right? So let's multiply both sides by b, and let's divide both sides by the period. Okay. So the quick way to go from here to here is just interchange B and period. So if you know the period, if we give you a graph, right? So think about all the stuff we've done to this point, right? We looked at the graph of an exponential function. We looked at the equation. We said, what does the equation tell us about the graph? What does the graph tell us about the equation? Okay? So same deal here. If I give you a graph, you can figure out the period because you're going to say, oh, I'm just going to start at the maximum and go back, go to the next maximum. That will be one period. Or I start at a minimum, go back to the next minimum. Let's say we got on a Ferris wheel. So if you get on a Ferris wheel, you start down at the bottom. Starts going around. You go up to the middle. You get up to the top. You go back to the middle. You get down to the bottom. You go back to the middle, up to the top. Sound familiar? From the midline to back. So we'll start at the bottom. We'll go up to the middle, to the top, back to the middle, down to the bottom. That's one period, right? We're back where we started. We're back at the bottom. So I give you a graph showing that. You can figure out the period. If you get the period, then you can calculate what the B value is. If I give you an equation, that's from a graph, right? Hey, here's a graph. Tell me about it. Here's an equation. You look at the B value, you say, if I go 2 pi divided by that B value, I will get the period. So we can give you an equation that describes temperature in Calgary, how it varies through the year. And you can work out stuff from the equation. Which leaves one last thing, which is C. So let's set B back to 1. We'll leave B as 1. B as 1 is fine. Let's clean this up. So this is the basic sinusoidal function, right? Just as we had the basic exponential function, usually like 2 to the x or 10 to the x, basic log function, basic quadratic, y equals x squared, cubic, y equals x cubed question.
Really can actually picture be like kind of help use the triple line.
No. It's if you do 3-1, you would say there's a horizontal stretch by a factor of 1 over b. Okay, but it isn't really, it's not a thing, right? See, A and D are things. Like D, that is the midline. That tells me, it gives me the equation, right? I can say the median value is 5. I can say the equation of the midline is y equals 5. You tell me the amplitude, I can say, oh, so if the midline is at 5 and the amplitude is 2, then I know from the middle at 2, I'm going to go up 2 to get to 7. I'm going to go down 2 to get to 3. So now I can tell you what the minimum and maximum values are for this function based on those two numbers, A and D, because they actually are something. B, that's why it says B is not the period, but you can use it to calculate the period. And then we've got C. Somewhat anticlimactically hitting C. Okay, where's it going? Which way? Left or right? So C moves it left or right. Does the shape change? So is the shape changing? Is it getting taller? So A is going to change the shape, right? It's going to make it taller, vertically stretched, or smaller. B is going to change the period. That changes what it looks like horizontally, right? There could be more periods in less space, or less periods in more space. You could spread it out horizontally, or that. C. No, apparently I can't. There. I'm going to put C back to 0. So that there's no shift. Okay, so C is called the phase shift. Oh, D, by the way, formally, D is called the vertical displacement. Vertical displacement. Okay, so if any of you want to do Math 30-1 after this, then you'll hear D referred to, because you will study sinusoidal, and you'll have D referred to as the vertical displacement.
That's kind of the middle after step.
Which one? D?
Yeah, no, C.
C. No, so C C would kind of be more the y-intercept, right? Because it's actually, you can't do this. On the old notes, the non-PDF notes, I can extend the page forever. You should still have some room though. So C is called the phase shift. Phase shift. And it moves the graph left or right. So essentially, as far as C goes, you need to know about as much about C as you do about radians. It exists, it moves the graph left or right. You're generally not responsible for values of it. However, I think you should know more than is necessarily required. So we will look at C, and I will give you a special formula that we're going to use, and I will put it on the test. So we're not going to give you the formula sheet for the test because it's only got these two formulas on it. I'm just going to put them on the top of the test. Okay, so I'll give you that along with something that I call the start point, right? And we'll worry about the start point tomorrow, but it uses C. Okay, so there will be a few questions involving C that you will have to answer during this unit. Generally on the diploma, there will be nothing to do with C, right? You just keep in mind, it just moves the graph left or right.